Hello, this is your final review assignment. Remember that this is worth points toward your final. If you're in the accelerated class, it's worth 20 points. If you're in the prep class, it's worth 30 points. I'm putting both classes on one assignment, so if it looks a little different than your study guide, skip over that part and move on to the ones that you need. If you're in the accelerated class, you're going to want to go ahead and fast forward to where chapter 6 starts. If you are in the prep class, stay here. Are the given lines parallel, perpendicular, and neither? Remember that parallel has the same slope, perpendicular have opposite reciprocal slopes. So here, 5, remember it's in the form y equals mx plus b, m is our slope. 5 and 1/5 are our slopes. While they are reciprocals of each other, they're not opposites, meaning one's not positive and one's not negative. So that means this one is neither. Here we have slopes of 3, so that means they're parallel because they're the same. And here we have negative 4/3 and positive 3/4. That means that they are perpendicular because they are opposite reciprocals. Create a line of best fit for the scatter plot below. So on this one, what we want to do is, the easiest is to write it in the form y equals mx plus b. The way to do that, however, would be to have our y-intercept and our slope. So let's find that. Here we have our y-intercept, so that means that b equals 1. And you pick a line to go through. I like that point there. It looks like it goes through nicely into all of the other points. So I need to calculate my slope. Slope is rise over run, so we go up 1, 2, 3, 4. Up 4, we go right 1, 2, 3, 4. Right 4. So that means that our slope is 4 over 4. 4 over 4 reduces to 1. So our final equation is y equals 1x plus 1. Or since we don't really even need to say 1x, we can just say y is x plus 1. Describe the shifts that occur anytime you're adding on the inside, you're moving left. When you're subtracting on the inside, you're moving right. When you're adding to the outside, you're moving up. When you're subtracting from the outside, you're moving down. And when there's a negative on the outside, it flips the graph. Solve using elimination or substitution. Here where we have two y equals, it's easiest just to set them equal to each other. Negative 7x minus 12 equals x plus 12. We'll add 7x to both sides. We get negative 12 equals 8x plus 12. Subtract 12 from each side. We get negative 24 equals 8x. Divide by 8. Negative 3 equals x. Once you have negative 3, we need to take that and plug it into one of our original equations to find y. Y equals negative 3 plus 12. So that means y equals 9. Remember to write your final answer as an ordered pair, x comma y, so it would be negative 3 comma 9. Again, we can solve with whichever method we want. I see here I don't have it solved for one variable, but I have two variables that could easily cancel out. If I could turn my negative 3x into a negative 6x, I could add my x's together and they would cancel out. So I'll multiply the bottom equation by 2. My new problem, the first one, is still there. 6x minus 3y equals 21. And when I multiply the bottom equation by 2, I will get negative 6x plus 12y equals negative 6. We'll add our equation straight down. 9y equals 15. And we need to go ahead and solve for y, so we'll divide by 9, divide by 9. Y equals 15 over 9, but we can reduce that by dividing by 3, and we will get 5 over 3. Now remember, we're not done. We need to also solve for x now. So we'll take one of our original equations and plug it in. 6x minus 3 times 5/3 equals 21. So 6x, this is like 3 over 1, we'll multiply straight across, minus 15 over 3 equals 21. 15 over 3, that's just like saying 5, because that's 15 divided by 3. We'll add 5 to both sides. We have 6x equals 26. Divide by 6. X equals 26 over 6. We can divide that again by 2 over 2. And we get x equals 13 over 3. When we write our final answer, x comma y, that's 13 over 3, comma 5 over 3. Next, solve the system of inequalities by graphing. Remember, this is y equals mx plus b. You always start with your y-intercept, then you use your slope. So if our y-intercept for the first equation is negative 5, our slope is 3, which is like 3 over 1. So we'll go up 1, 2, 3 over 1. I like having more points so that my lines look nice, so I'm going to go up 3 and over 1 again. Up 3 and over 1 again. You can do that as many times as you want to make your line nice and straight. Since its y is greater than, it's just going to be a dashed line. And then we have to remember to do the shading. If it's greater than, you'll shade above the line. If it's less than, you'll shade below the line. So here we will shade above the line because its y is greater than. Next, we'll move on to the second equation. For our second equation, we have y is less than or equal to 1/2 x minus 3. So our y-intercept is at negative 3. And it says 1/2, so we'll go up 1, right 2. Up 1, right 2. Remember, it's rise over run. And then since it's less than or equal to, it's a solid line. And since it's less than, we will shade below the line. Now remember what I told you, what I'm looking for, make sure you shade completely below the line, because what I will be looking for when I grade it is that one overlapping section actually overlaps. If the two don't actually overlap, then that means you shaded incorrectly. Right here is what I'm talking about, how there's green and blue right in that section. Okay, so I'll be looking for whether you have solid lines or dotted lines, and I'll also be looking at your shading. Okay, simplify the expression. So first thing, it's just like PEMDAS. First thing, we need to look at our exponents here. So 3, when you raise a power to a power, you multiply. So we have x squared times x to the 12th power, y to the negative 9th power, over y squared. Anytime you have a negative exponent, it means it belongs on the other side. So we now have x squared times x to the 12th over y squared times y to the 9th. Keep on going. When you're multiplying the same base with different exponents, you're going to add together the exponents. So we will have x to the 14th over y to the 11th. And that is our final answer. Write the expression in radical form. Remember, radical form looks like this. Whatever's inside those parentheses will go inside. Your numerator will be what you raise the whole thing to. So if we're raising it to the first power, it's not really going to change. The denominator is there, which means, is it a third root? Is it a square root? Is it a fourth root? Etc. So we want to try to simplify it. 2 means what number multiplied by itself 2 times equals 16, and so we know that would be 4. And we don't know what the square root of x is, so we'll leave it as the square root of x. We don't need that 2 there because the second root and square root mean the same thing, so we can leave it just like this. Now we need to go the other way, write it as a power with a rational exponent. So remember, our numerator is whatever our exponent was, and our denominator is whatever was outside of the radical. Write a recursive formula to represent the geometric sequence. I will give you the equation. You just have to remember that you need to find A1, which is first term, and R, which is the rate. What are you multiplying by each time? We're multiplying by 4. So when we rewrite the equation, it's AN equals AN minus 1 times 4. A1 equals 5. And that's all you need to know how to do. I'm not asking you to find the 6th term or the 100th term or anything like that. You just need to know how to write out the equation. Same thing for the second one. I'll give you the equation. You just need to find A1 and R. So A1 is 7. Our rate, what are we multiplying by? We're multiplying by 3 every time. So AN equals 7 times 3 to the n minus 1 power. Here we have an exponential function. We know it's exponential because it's written like y equals a times b to the x power. So that means that we just need to use our numbers that we always use, -2, -1, 0, 1, and 2. And we'll plug those in. -12 times 2 to the -2 power. That is like -12. Or sorry, not -12, -1/2. When we have a negative exponent, it flips it over to the other side, so times 1 to the 2 squared. Keep on simplifying it out as much as you possibly can. So that's -1/2 times 1/4, which will be -1/8. We'll keep on going. -1/2 times 2 to the -1 power. That is like saying -1/2 times 1 over 2 to the 1 power, which again, 2 to the first power is just 2, so we have -1/2 times 1/2, and that's -1/4. We'll keep on going, plug in 0, -1/2 times 2 to the 0 power. Anything to the 0 power is just 1, so this is -1/2 times 1. And anything times 1 is just itself. So here we will have -1/2. Then -1/2 times 2 to the first power. 2 to the first power is just 2. So we have -1/2 times 2, which is like 2 over 1. We'll multiply straight across, and we get -2 over 2. And -2 over 2 reduces to just be -1. -1/2 times 2 squared. That is like -1/2 times 4, which is like 4 over 1. And when we multiply that one straight across, we get -4 over 2. Reduce that, -4 over 2 is like -2. So the tables on the previous slide gave us these points here, and we'll just go ahead and plot them. -2 and -1/8, that'll be just underneath the x-axis. -1 and -1/4. Remember, the smaller the denominator, the further away from 0 it is. The bigger the denominator, the closer it is to 0. So when we're doing those fractions, we're kind of estimating. 0 and 1/2, 1 and -1, 2 and -2. Once you have those values, we draw our line through. Did we expect it to look like this? Yes, we did, because it's an exponential function and they kind of look like slides. Alright, so I hope in class you wrote down what A, P, R, N, and T stand for. So we'll go through. A customer deposits $3,500 in the savings account. That is the price or the principal amount, so that'll be our P. Into a savings account that pays 7.04% interest. That's our rate, but remember it has to be written as a decimal, so we'll move that twice to get rid of our percentage, and we have 0.0704, and that will be our rate. Compounded annually. Annually is the number of times each year, and that's 1, so that'll be our N. Write an equation that shows how much money the customer will have in the account after 8 years. 8 years is our time in years, and so that will be T. Now we just go through and plug in. A equals 3,500 times 1 plus 0.0704 over 1 to the 1 times 8 power. The only way this one might difference is I would probably simplify 1 times 8 to just be 8. And if I had a fraction over 1, I wouldn't really need to put it over 1. But as long as you know about how to plug this in, you're set. Tell whether the function represents exponential growth or decay. Remember, we have y equals a times b to the x. B is our factor. If it's greater than 1, it's growth. If it's less than 1, it's decay. Looks like on both of these equations, I was being sneaky with you. So 3 here, it's greater than 1, so that's growth. And 3 here, also greater than 1, so that's growth. Pay attention to that. Whether, don't just be tricked by the A term. We're only looking at the B term. So a new car is worth $17,000. You can use that function to estimate the car's value after X years. What is the decay factor and what does it mean? The decay factor is 0.65. And what that means, and you can word this however you want, that means that the car only has 65% of its value after each year. So I like wording it as each year the car loses 35% of its value, because 100 minus 65 is 35. So you can say it's only worth 65% of its value each year, or it loses 35% each year. Up to you, however you want to word that, as long as you kind of understand that whole concept. Write the polynomial in standard form. Standard form just means the largest exponent down to the smallest one. So we have negative 5x to the 9th minus 7x to the 7th plus 13x to the 3rd plus 3x. That's standard form. Classify the polynomial by degree and number of terms. The degree is 2, so that means it's quadratic. And there are 3 terms, so it's a trinomial. Again, those might be something you want to write on your note card. Simplify, write in standard form. When we have an addition sign here, remember you're not foiling. We're just adding. We're just combining like terms. So 7x squared, it doesn't match anything in the first trinomial, so I'll just put it in between the 3 and the x term. Or sorry, the cubed term and the x term. And then plus 4 matches up with the 9, so we add straight down 6x to the 3rd plus 7x squared minus 3x plus 9 plus 4 is 13. When we subtract, we need to distribute the subtraction sign out to each term. It'll change all of those signs, so it'll be a negative 7x squared, it'll be a positive 2x, and it'll be a negative 6. Adding straight down, 2x squared plus 5x minus 5. That is your final answer. Simplify each product. So here we're just distributing. So we have t to the 5th minus 2t to the 4th plus 3t squared. Number 6, we have binomials, so we're going to have to FOIL. We have 16x squared. 8x times negative 5 is negative 40x. Negative 1 times 2x is negative 2x. And negative 1 times negative 5 is a positive 5. So our final answer is 16x squared minus 42x plus 5. Now here when we have a squared, remember what we're doing is we're multiplying the binomial by itself. Okay, you can't just square the terms inside. We have to actually write it out this way and do some FOILing. So we get 36x squared minus 12x minus 12x plus 4. So 36x squared minus 24x plus 4. And that's our final answer. Now when we have a binomial and a trinomial, we can't just FOIL, but it's the same idea where we say, okay, I want each part of the first term to multiply to each part in the second terms. So we get 3x to the third, then 3x times 2x will be 6x squared. 3x times 7 will be 21x. Then moving on to 2, since 3 multiplied to each of those, now we'll do 2. 2 times x squared is 2x squared. 2 times 2x will be 4x. And 2 times 7 will be 14. We need to go through and combine our like terms. 6x squared and 2x squared, 21x and 4x. So our final answer is 3x cubed plus 8x squared plus 25x plus 14. Find the GCF. This one, all we have to do is find it. We don't have to actually factor it out. What number goes into 24, 36, and 42? The largest number, okay, because yes, 2 goes into all of them, but you have to look for the largest one. So our largest number would be 6. And then you look at the variables, they all have an m, and then we'll pick the smallest exponent, 5, because that means that there are at least 5 m's in the first term, at least 5 m's in the second term, and at least 5 m's in the third term. So that's our answer, GCF. Factor completely. So we need to look through on number 10 and see what goes into each of those since it's just a binomial. So 7 goes into each of those. They each have an x. The smallest exponent is a 4. They also each have a y, and the smallest exponent is a 3. The factoring part says, okay, now let's divide that out and what's left. 14 divided by 7 is 2. X to the 7th divided by x to the 4th. That'll be x to the 3rd. Y to the 3rd divided by y to the 3rd, it's just 1, so we're done. Plus 21 divided by 7 is 3. X to the 4th, take out x to the 4th, and nothing left. Y to the 9th, take out y to the 3rd, and we're left with y to the 6th. And we're done, factoring. You have your GCF, then you have what's left when you divide it out. Here, old-fashioned factoring, what multiplies to be negative 16 but adds to be negative 8. I know that there's 1 and 16, there's 2 and 8, 3 doesn't go into it, 4 and 4. We know they need to multiply to be negative and add to be negative, so my largest terms would have to be negative. Looking at that, I see it'll be x plus 2 and x minus 8, because 2 times negative 8 is negative 16, 2 plus negative 8 is negative 6. Here we have a coefficient in front of our x squared, so that means we get an x box. So 3 times negative 3, that'll be a negative 9x squared. Negative 8 goes on the bottom. What two numbers multiply to be negative 9 but add to be negative 8? That would be a negative 9x and a positive 1x. Go through, put that in our box. And first term, first box, that's 3x squared. Last term, last box, that's negative 3. Then we'll plug in our side terms that we found, negative 9x and 1x. We need to divide out our greatest common factors. So, greatest common factor of 3x squared and negative 9x is 3x. Greatest common factor of 1x and negative 3 is just 1. Greatest common factor of 3x squared and x is just x. Greatest common factor of negative 9x and negative 3 is a negative 3. Multiply everything back in to double check your answers. And our final answer is 3x plus 1, x minus 3. Second one, we again have a binomial. Looks like it's a perfect of squares, so we'll square root each part. And we get x. Square root of x squared is x. Square root of 121 is 11, so we have x plus 11, x minus 11. Remember, if it was like a 4x squared, it would be 2x and 2x. Factor by grouping. Grouping, we group together each terms and divide out their greatest common factor. Greatest common factor of the first one is, oh, whoops, I messed up, and don't make this mistake. First, we need to look for Greatest common factor of all of these, a 2 would divide into each one of these, so we'd be left with 3n to the third power plus 3n to the second power plus 5n plus 5, because we divided out that 2. Now we'll go ahead and group our terms and divide out those greatest common factors. So we still have our 2 on the outside that we divided out. Greatest common factor of 3n to the third power and 3n squared would be 3n squared, and we'd be left with n plus 1 when we divide that out. Then on the second part, we'll divide out a 5, because that's the greatest common factor, and we'll be left with n plus 1. So now we need to do the actual combining part, the whole factor by grouping. So that 2 is still on the outside, and we'll be left with 2 sets of parentheses, 2 binomials. Whatever was left on the outside, whatever we factored out, goes into one of them. And then the repeated ones go in the other one. And that is our final answer. For prep, this is your last chapter. For accelerated, it's your second to last chapter. We're almost there. Hang in there. What's the standard form of a quadratic equation? That's y equals ax squared plus bx plus c. What's the equation for axis of symmetry? That's x equals negative b over 2a. What is the quadratic formula? That's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And what is the discriminant? Well, that's just the inside part of the radical, negative b squared minus 4ac, sorry. Just b squared minus 4ac, not negative b squared, just b squared over minus 4ac. What are the solutions of the graph? Remember, solutions are what x equals, or what x equals when y is 0. So those will be our x-intercepts. So that's x equals 0 and x equals 6. Those are our solutions. Now here we're graphing a quadratic equation, which means we need to use our negative b over 2a to figure out where the vertex is. So a is 2, b is 8, c is 2. So we plug that in, we get negative 8 over 2 times 2. That's negative 8 over 4, which is negative 2. So that means we'll start with negative 2. We'll go 2 numbers up. We'll go 2 numbers down. Now we'll go ahead and plug everything in. We have 2 times negative 2 squared plus 8 times negative 2 plus 2. So that's 2 times 4 plus negative 16 plus 2. So that is 8 minus, what's negative 16 plus 2? That'll be negative 14. And 8 minus 14 will be negative 6. Now you get to pick which way you want to go. I'm going to move up to negative 1. I like dealing with smaller numbers. So 2 times negative 1 squared plus 8 times negative 1 plus 2. So that's 2 times 1 minus 8 plus 2, which is 2 minus 6, which is negative 4. Keep on moving. 2 times 0 squared plus 8 times 0 plus 2. That's 0 plus 0 plus 2, which is just 2. Now remember, we're just going to reflect those over. That's the beauty of quadratics. You get to do half the work. So all of the points I've written in the bottom corner are the points that we got from our table in the previous slide. So we'll go ahead and plot all of those. 0, 2, negative 1, negative 4, negative 2, negative 6, negative 3, negative 4, and negative 4, positive 2. Go ahead and draw your line through. Make it look like a parabola as much as you can. Your vertex, that's always your middle point. So our vertex is -2, -6. It formed a minimum because that's the lowest point of our graph. Domain, again, that's x values. If we zoomed all the way out, how far left, how far right would it go? That would be all real numbers. And range, that's our y values. Where do our y values start? Well, they start down at -6 and everything above -6. So y is greater than or equal to -6. Solve the equation using square roots. So we'll subtract 108 from both sides. We have 3x squared equals -108. Divide by 3, divide by 3. We get x squared equals -36. Now, in order to figure out what x is, we need to take the square root of both sides, but we can't take the square root of a negative, so this one would be no solution. Solve the equation by factoring. So we need two numbers that multiply to be 80 but add to be 24. So since we want them to multiply to be a positive but add to be a negative, we know they'll both be negative. So we can have 1 and 80. We can have 2 and 40. We can have 3 and, nope, 3 doesn't work. We can have 4 and 20. Oh, right there I see 4 and 20 would make 24. So again, we said we want them both to be negative, so that's x minus 4, x minus 20 equals 0. If we have two things that multiply together equals 0, we know that one of them has to be 0, so either x minus 4 equals 0 or x minus 20 equals 0, which means x either equals 4 or x equals 20. And those are our two solutions. Solve the equation by completing the square. So remember, with completing the square, the first step is to write it with a space there. And what goes in that space will be half of b squared. So half of b is 10, so we're going to add 10 squared to both sides. So our equation becomes x plus 10 squared. Remember, we do completing the square because it will factor perfectly like that every time, equals 121. We'll go through, square root both sides. We get x plus 10 equals plus or minus 11. Then we will subtract 10 from both sides. And we get x equals -10 plus or minus 11. Since we know what the square root of 121 was and we turned it into 11, we need to break this down all the way. -10 plus 11 and -10 minus 11. So that gives us 1 and -21 as our solutions. Find the number of real number solutions in the equation. This is when we use our discriminant, b squared minus 4ac. If you get a positive number, that's two solutions. A negative number is no solutions, and 0 is one solution. Before we can figure out a, b, and c, it has to be a trinomial equal to 0. So that's 5x squared minus 5x minus 2. Equals 0, sorry. And once we get that, we know a is 5, b is -5, and c is -2. So we'll go ahead and plug it into our discriminant, and we get -5 squared minus 4 times 5 times -2. So that's 25 minus 4 times 5 is 20. -4 times 5 is -20 times -2 will be a positive 40. And 25 plus 40 is 65. That's a positive number, so that means it'll be two solutions. Solve using the quadratic formula. Again, before we can use a, b, and c, it needs to be a trinomial equal to 0. So 6x squared plus 5x minus 12 equals 0. So a is 6, b is 5, c is -20. So we'll plug that into our quadratic formula, which is -b plus or minus the square root of b squared minus 4ac all over 2a. So when we work it out, negative b, that'll be a negative 5, plus or minus the square root of b squared, that's 5 squared, minus 4 times 6 times negative 2, all over 2 times 6. So we'll solve it out. Negative 5 plus or minus the square root of 25. Negative 4 times 6 is negative 24. Times negative 2, that will be a positive 48. All over 12. Again, keep on simplifying. That's negative 5 plus or minus the square root of 73. Do we know the square root of 73? I certainly don't. So we will leave it just like that. Match the graph with the type of function. The first one is an absolute value function, so that's D. 13, it is a parabola, so that's a quadratic function, which is C. 14 is a line, so that means it's a linear function. And 15 is a slide, so that's an exponential function. If you're in the prep class, so periods 4, 6, and 1, you guys stop here. You're done. If you're in the accelerated class, we've got one more chapter. Solve the system using the method of your choosing. We have two things equal to y, so we might as well just set them equal to each other. X squared minus 2x plus 3 equals negative 2x plus 28. So we want to try to get them all equal to over to one side. So we'll add 2x to each side. Our 2x's are going to cancel out. We'll get x squared plus 3 equals 28. Now we might as well, since we only have an x squared term, just solve for x using our square roots. So we'll subtract 3 from both sides. X squared equals 25. Have to square root both sides, so we get x equals plus or minus 5. Now once we found x, we need to also find y. So remember, we have two answers. We have positive 5 and negative 5. So y equals negative 2 times 5 plus 28. So that's y equals negative 10 plus 28, which means y equals 18. And then our second equation is for what if it was negative 5. So y equals negative 2 times negative 5 plus 28. So y equals positive 10 plus 28. So y equals 38. Remember to write your answers as a coordinate pair. So we have positive 5, 18, or we have negative 5 and 38. Find the missing side lengths of the diagram below. So we're going to use, sorry I didn't mark that, it's a right triangle. So we're going to use Pythagorean theorem, a squared plus b squared equals c squared. So 3 squared plus 4 squared equals c squared, or x squared. 9 plus 16 equals our third length squared. So 25 equals c squared. We need to just find c. So we're going to square root both sides. And we have c equals plus or minus 5. But do we ever have a negative distance? No, we do not. So that means that our hypotenuse is just positive 5. Do the side lengths below form a right triangle? Remember, c is always going to be your largest side. So is 25 squared plus 36 squared equal to 61 squared. Now, this is where having a calculator will be very helpful. So 25 times 25 is 625 plus 36 times 36, that's 1296, and 64 squared is 4096. Is 625 plus 1296 equal to 4096? No, it's not. So, no, they do not form a right triangle. Simplify the radical expressions. So, whenever I have a fraction inside, I like to reduce my fraction first. 9 divided by 3 is 3. X to the 5th divided by x to the 3rd is just x squared. That makes it so much easier because now I'll go ahead and go through. The square root of 3, I don't know it. This is like the square root of 3 times the square root of x squared. When we're taking the square root of something with a variable and an exponent, we just take half of the exponent. So that is like the square root of 3 times x. I like to rewrite those with the one outside the radical in front, so it's x squared root of 3. Second one, we're multiplying, so we need to go ahead and distribute that across. So we have 5 times the square root of 3 times the square root of 27. That is times the square root of 81, plus 5 square root of 3 times square root of 4, square root of 12. We need to go ahead and simplify that. Square root of 81 is 9, so that's 5 times 9, plus this is 5 times square root of 12 can break down to be square root of 4 times the square root of 3. So we get 45 plus 5 times 2 times the square root of 3, which becomes 45 plus 10, the square root of 3. Keep on going, simplifying. 9 square root of 2, we can't break that one down anymore. 50 can be the square root of 25 times the square root of 2. Remember, you always want to look for a perfect square that can factor out. So that's 9 square root of 2 plus 5 square root of 2. Since they both have the same radical, we can combine them, and we get 14 square root of 2. Next, we're not allowed to have square roots in our denominator, so since we have a binomial down here, we're going to have to multiply by the conjugate. The conjugate is square root of 3 minus 2. So times the square root of 3 minus 2. We'll go through, and the top becomes 6 times the square root of 3 minus 12 over the bottom. Remember, since we're multiplying conjugates, our outer and inner terms will cancel when we do the FOIL method. So we're just going to go ahead and multiply our first and last terms. So square root of 3 times square root of 3 is just 3. 2 times negative 2 is negative 4. 3 plus negative 4 is over negative 1. We can simplify that more, and we will get negative 6 square root of 3 plus 2, because we have to do 6 divided by negative 1 and negative 2 divided by negative 1, which will get us this as our final answer. Solve and check for extraneous solutions. So we'll square both sides. X plus 2 equals 25. Subtract 2, subtract 2. So x equals 23. Now we need to check for extraneous solutions, so we need to go back and plug it in. Is the square root of 23 plus 2 equal to negative 5? So is the square root of 25 equal to negative 5? Is 5 equal to negative 5? No, it's not. That's an extraneous solution. Here we'll square both sides. 2x plus 14 equals 9x. We need to go ahead and solve, so we'll subtract 2 from both sides. 14 equals 7x. Now we'll divide by 2 on both sides, by 7 on both sides. X equals 2. Now we need to go in, plug it in, and check for extraneous solutions. So, is the square root of 2 times 2 plus 14 equal to the square root of 9 times 2? So, is the square root of 18 equal to the square root of 18? Yes, it is. That's the solution. Woo! Last one. So, describe the shift that occurs. So, here, this is going to go up 12. This one will go left 12, this one will go down 12, and this one will go right 12. Now, there's a lot of pressure to have the best joke ever since this is the last video, but I just don't even know. There are just so many great ones, so many wonderful ones. I'm tempted to tell my Egypt joke, but it literally takes 15 minutes, and this video is already so long. So, here's what I'm going to go with. Why do elephants always get kicked out of public school? They can't stop dropping their trunks.